NASA just announced the discovery of 500 new planets. They're all orbiting other stars, not our sun, but one of them shares some similarities with Earth.
The potential is there, and it's very exciting because in the catalogs of planets that we now have, this is the first time we've had an Earth-like planet in the habitable zone of a sun-like star.
What if I told you, Earth might not be the best planet for life in the universe? For billions of years, we've believed our planet hit the cosmic jackpot. Perfect distance from the sun, liquid water, a stable atmosphere, life everywhere. But recently, headlines started spreading across the internet claiming something shocking. Scientists may have identified 24 planets that could be even better for life than Earth. Better than Earth? That sounds like we just found lush alien jungles, blue oceans, maybe even advanced civilizations staring back at us through the stars. But pause for a second. No alien cities were discovered. No strange signals were detected. No photos of glowing forests or floating mountains. So what actually happened? Scientists didn't find life. What they found was something more subtle, and in many ways, even more exciting. They studied thousands of distant planets and asked a bold question. If we could design the perfect world for life, would it look exactly like Earth, or slightly different? The answer led to a fascinating idea called superhabitable planets worlds that might have conditions even more friendly to life than our own. Not confirmed Earth 2.0. Not proven to be alive. But planets that, on paper, could offer life more time, more stability, and maybe even better environments to grow and evolve. And tonight, we're breaking it all down: what superhabitable really means, how scientists narrowed 4,500 planets down to just 24, why most of them aren't even fully confirmed yet, and whether any of them could truly host life. If you're fascinated by space, evolution, and the big questions about our place in the universe, make sure you're subscribed to Evolvex, because this is where curiosity evolves. The truth behind those headlines? It's far more interesting than you think. Let's dive in. What does superhabitable mean? Before we talk about the 24 planets, we need to understand something important. Earth might not actually be the most optimal planet for life in the universe. That sounds shocking at first, because Earth is the only place we know that supports life. But when scientists study planetary evolution, climate history, and long-term stellar behavior, they see that Earth has gone through extreme changes. There have been mass extinctions, global ice ages, asteroid impacts, and long-term changes in the sun's brightness. Earth works, clearly, but that doesn't automatically mean it represents the best possible conditions life could ever have. Because of this, researchers began asking a fascinating question. If we could imagine a planet that is slightly better suited for life than Earth, what would it look like? This idea was explored in a scientific paper published in the journal Astrobiology by Ren Heller and John Armstrong in 2014. They introduced the concept of superhabitable worlds, planets that may offer conditions even more favorable for life than our own planet does. Their work did not claim such planets are inhabited, but rather that certain physical characteristics could make them potentially more life-friendly over long timescales. According to this research, a superhabitable planet might be slightly larger than Earth, which could help it retain its atmosphere for longer periods due to stronger gravity. It might also be a few degrees warmer on average, which could increase biodiversity, since warmer climates on Earth tend to support more species. The planet could have more shallow oceans and archipelagos, creating diverse coastal ecosystems. It would ideally orbit a K-type dwarf star, which burns cooler and far longer than our sun, potentially giving life tens of billions of years to evolve. However, it is very important to understand that superhabitability is a theoretical framework. Scientists have not directly observed oceans, oxygen, forests, or animals on these planets. Most exoplanets are detected through indirect methods, such as the transit method used by NASA's Kepler Space Telescope, where a planet is identified by the small dip in brightness it causes when passing in front of its star. This means we often know only the planet's size, orbital distance, and sometimes rough temperature estimates. Out of roughly 4,500 known exoplanets and planet candidates cataloged so far, researchers applied filters based on age, size, star type, and estimated surface conditions to identify 24 strong superhabitable candidates. None of these planets meet every ideal condition perfectly. They are simply the best combinations we have found so far based on limited data. How they chose the 24. So how exactly were these 24 planets chosen? Researchers began by looking through thousands of known exoplanets and planet candidates discovered mainly by NASA's Kepler Space Telescope and other surveys. Today, more than 4,000 exoplanets have been confirmed, with thousands more listed as candidates in scientific catalogs. These discoveries are stored in public databases such as the NASA Exoplanet Archive, which scientists use to compare planetary size, orbit, and star type. From this massive pool of worlds, researchers filtered out the ones that best matched their superhabitability criteria. The first major factor was age. Earth is about 4-5 billion years old, and complex life took billions of years to evolve. For most of Earth's history, life existed only in simple microbial forms. Multicellular life appeared much later, and intelligent life only emerged very recently in cosmic terms. Because of this, scientists reasoned that slightly older planets, estimated to be between about 5 and 8 billion years old, might have had more time for biological complexity to develop. Stellar ages are estimated through models of stellar evolution, which NASA explains in its overview of how stars live and change over time. The second factor was size. Many of the selected candidates are slightly larger than Earth, sometimes described as super-Earths. A planet modestly bigger than Earth could have stronger gravity, which helps it hold onto a thick atmosphere for longer periods. A stable atmosphere is crucial for regulating temperature and protecting potential life from radiation. However, if a planet becomes too large, it may accumulate thick layers of gas and resemble a mini Neptune rather than a rocky world. NASA provides a clear explanation of super-Earths and how they differ from gas giants on its exoplanet exploration pages. Temperature was another important filter. Scientists considered planets that might be slightly warmer than Earth on average. On Earth, regions with warmer and wetter climates, such as tropical zones, tend to support higher biodiversity compared to colder regions. A planet that is a few degrees warmer globally, but not overheated like Venus, could theoretically support more widespread ecosystems. The concept of the habitable zone, where temperatures may allow liquid water to exist, is explained in detail by NASA's Planetary Science Division. Water potential was also considered. Although we cannot directly see oceans on these distant worlds, scientists estimate whether a planet could support liquid water based on its distance from its star and the star's brightness. Liquid water is considered essential for life as we know it, which is why NASA's astrobiology program often describes the search for life as "follow the water." More about NASA's approach to water and habitability can be found through the astrobiology program website. Finally, one of the most important criteria was the type of star the planet orbits. Many of the top superhabitable candidates orbit K-type dwarf stars, which are slightly smaller and cooler than our Sun. These stars burn their fuel much more slowly and can remain stable for tens of billions of years, far longer than the Sun's estimated 10 billion year lifespan. A longer-lived star gives potential life much more time to emerge and evolve. NASA's overview of stellar classifications explains how different star types vary in size, temperature, and lifespan. It is important to remember that these conditions are estimated using indirect measurements. Most exoplanets are discovered using the transit method, where scientists observe tiny dips in a star's brightness as a planet passes in front of it. From this, researchers can estimate the planet's size and orbital period, but not directly confirm oceans, continents, or life. NASA explains how the transit method works and what it can and cannot tell us on its Kepler mission pages. Important reality check. Now here's where things get grounded in reality. Most of these 24 objects are not confirmed planets. They are classified as Kepler Objects of Interest, or KOIs. A KOI is a signal detected by the Kepler Space Telescope that looks like it might be caused by a planet passing in front of its star. When a planet crosses its star from our point of view, it creates a tiny dip in brightness. Scientists analyze these dips carefully, but not every signal turns out to be a true planet. Some require more data and follow-up observations before they can be confirmed. Out of the 24 superhabitable candidates often discussed, only 2 are confirmed exoplanets: Kepler 1126b and Kepler 69c. The rest remain candidates listed in astronomical catalogs. Confirmation usually requires additional observations or independent verification methods to rule out false positives such as binary stars or background interference. Another important reality check is distance. Most of these planets are located hundreds or even thousands of light years away from Earth. A light year is the distance light travels in 1 year, which is about 9.46 trillion kilometers. At those distances, we cannot take direct images of their surfaces. Even the James Webb Space Telescope, which is currently the most powerful space telescope ever built, focuses mainly on studying atmospheres of selected nearby exoplanets and cannot directly observe oceans or continents on small rocky worlds so far away. Because of these limits, we do not yet know whether these planets have oceans, breathable atmospheres, clouds, continents, or thick uninhabitable atmospheres like Venus. Most of what we know comes from measurements of size, orbital distance, and star type. Superhabitable does not mean inhabited. It means that based on theoretical models, certain conditions could be favorable for life. The confirmed planets. Let's start with the 2 confirmed planets often mentioned in discussions about superhabitability: Kepler 1126b and Kepler 69. These are not just signals in a dataset. They are validated exoplanets that have been confirmed through follow-up analysis and are listed in official astronomical archives. Unlike most of the other objects in the 24 candidate discussion, these 2 have passed the verification process required to move from candidate to confirmed planet status. Kepler 1126b, also known as KOI 2162-01 during its candidate phase, is considered a super-Earth. It is larger than Earth and orbits within what scientists call the habitable zone of its star, meaning it receives a level of starlight that could allow liquid water to exist under the right conditions. However, being in the habitable zone does not guarantee that water is actually present. We currently know its size and orbital period, but we do not yet know its atmospheric composition, surface pressure, or whether it is rocky, water-rich, or surrounded by a thick gas envelope. Kepler 69c, also known as KOI 172-02, generated major excitement when it was first announced, because early estimates suggested it might orbit within the habitable zone of a Sun-like star. Over time, improved models of the star's brightness and the planet's orbit suggested it may actually receive much more radiation than originally thought. Some later analyses proposed that it could be more similar to Venus than Earth, potentially too hot for liquid water on its surface. These 2 planets highlight something very important about science. Early results can look promising, but as measurements improve, interpretations can shift. A world that seems Earth-like at first may later turn out to be too hot, too large, or too different in composition. This process of revision is not a weakness. It is how science moves closer to the truth. The full list of 24 superhabitable candidates. When scientists talk about the 24 superhabitable candidates, they are referring to a very special short list of worlds. These planets and planet candidates were selected from thousands of known exoplanets because, according to theoretical models, they could have conditions even more favorable for life than Earth. Among these, some of the most notable include KOI 5715-01, which is often highlighted as one of the strongest contenders, and Kepler 1126b, a confirmed planet also known as KOI 21621. Another confirmed planet on the list is Kepler 69c, also known as KOI 172-2, which initially excited astronomers as a possible Earth-like world. The list also includes several other promising Kepler objects of interest, such as KOI 555401, KOI 48781, and KOI 449701. These planets are all candidates identified using the transit method, where a planet passing in front of its star causes a slight dimming of the starlight, giving researchers a clue that a planet may exist. Some stars host more than one candidate in the Superhabitable shortlist, such as the system containing KOI 575.01 and its companion KOI 5752, both showing properties that make them theoretically more friendly to life. Other candidates on the list, these planets are all candidates identified using the transit method, where a planet passing in front of its star causes a slight dimming of the starlight, giving researchers a clue that a planet may exist. Some stars host more than one candidate in the Superhabitable shortlist, such as the system containing KOI 575.01 and its companion KOI 5752, both showing properties that make them theoretically more friendly to life. Other candidates on the list include KOI 5802.01, KOI 5553.01, and KOI 555402, which were all highlighted because of their size, age, and the type of star they orbit. Planets slightly larger than Earth, such as these, may retain their atmospheres longer and support diverse surface conditions. Additional candidates include KOI 6205.01, KOI 6811.01, and KOI 7003.01, all identified as having stellar and orbital characteristics that could allow stable, long-term climates favorable for life. Each of these planets is a candidate that deserves follow-up study when more powerful telescopes, like the James Webb Space Telescope, are used. Finally, a notable addition to this list is Kepler 1229b, a confirmed super-Earth that often appears in habitability studies. It orbits within the habitable zone of a red dwarf star, which is smaller and cooler than our Sun, offering the possibility of a stable environment for billions of years. Together with the other 23 candidates, Kepler 1229b represents the best combination of size, age, temperature, and stellar type among the thousands of planets we currently know, making these 24 worlds the prime targets in the search for theoretically superhabitable planets. Although none of these 24 worlds have been directly confirmed to host life, they stand out as mathematical shadows and planetary fingerprints. They are detected through light curves and indirect measurements, but their properties make them the most promising superhabitable candidates known to date. Each name on this list tells a story of careful selection, rigorous analysis, and the ongoing human quest to understand where life could exist beyond Earth. Other habitable zone worlds. Beyond the 24 superhabitable candidates, there are other well-known planets that often come up in discussions about habitability, though they are not necessarily part of this specific list. For example, Kepler 62e and Kepler 62e are two planets that orbit within the habitable zone of their star, meaning they receive an amount of starlight that could allow liquid water to exist under the right conditions. Scientists have studied these planets carefully because of their Earth-like sizes and orbital positions, which make them promising targets for understanding potential habitability. Other interesting candidates include Kepler 438b and Gliese 163c, which have been highlighted in several habitability studies. Kepler 438b is slightly larger than Earth and orbits a red dwarf star in the habitable zone, while Gliese 163c is a super-Earth that may have temperatures suitable for liquid water. Both planets are examples of worlds that could, in theory, support life if they have the right atmospheres and surface conditions, but we currently have no direct evidence for either. Finally, planets such as Kepler 440b and Kepler 296e also receive attention in discussions about potentially habitable worlds. Kepler 440b orbits in its star's habitable zone and is slightly larger than Earth, while Kepler 296 is part of a multi-planet system with other habitable zone candidates. Being in the habitable zone does not guarantee oceans or life. It only means that liquid water could exist if other conditions, such as atmospheric pressure and composition, are suitable. Why this research matters. So why does this research matter? The truth is, telescope time is incredibly limited and expensive. We simply cannot study all 4,500 known exoplanets in detail. That's where studies identifying the 24 superhabitable candidates come in. They give scientists a short list of the most promising worlds to focus on. This allows next-generation telescopes to spend their time wisely, targeting planets most likely to show signs of life. Some of the main tools for this next stage include the James Webb Space Telescope, which can analyze exoplanet atmospheres for chemical signatures, ESA's upcoming Plato mission, designed to find Earth-sized planets in habitable zones, and future flagship concepts like Louvre, which could study distant worlds in unprecedented detail. The ultimate goal is to detect atmospheric biosignatures, chemicals like oxygen, methane, water vapor, or ozone in the right combinations. If we ever observe these signatures, it could be the first hint that life exists beyond Earth. The 24 superhabitable candidates are not guaranteed to host life. Think of them as a scouting report, helping humanity focus on the planets most worth studying. So, did scientists actually find 24 planets better than Earth? Not exactly. What they found were 24 promising candidates. Worlds selected based on theory, probability, and careful models. Superhabitable does not mean inhabited. It simply means these planets might have conditions that could, in theory, be even more favorable for life than Earth. Earth remains the only planet we know for sure hosts life. That hasn't changed. But here's the beautiful part. The universe is vast, and possibilities are endless. If even one of these distant planets has oceans, or an atmosphere rich in oxygen, or signs of biological chemistry, then everything we thought we knew about life could change. We would finally have evidence that life isn't rare, it's cosmic. And maybe, somewhere out there, on one of those 24 distant worlds, life has already been evolving for billions of years longer than we have. We're just beginning to look, and every discovery brings us closer to understanding our place in the universe. If this blew your mind even a little, make sure to like this video, comment with your favorite cosmic mind-blower, and share it with friends. And don't forget to subscribe to Evolvex, where curiosity evolves.